So what we have discussed regarding friction almost over. Okay, numerical we have discussed. Now,
Sir,
let's talk.
today wrote a physics exam, sir.
Today you have okay.
Term one.
How's the exam
I
like?
wrote, sir. Sir, circular motion is, I don't know the concept of circular motion, sir.
Oh, no problem.
And also
MCQ.
there are questions like two balls are colliding each other. What will be the velocity? At what point will they meet? Like that they ask. I don't know, sir.
Those collision concept. Okay, don't worry.
Yes, sir.
Okay, I think collision will
That
come
came in
in.
5 mark questions.
Yeah, that is conservation of momentum. That is in collision chapter. I think momentum we will learn work energy power. Or in this chapter, I think let me check. Work energy power we will learn those things.
Okay.
But no,
Circular motion is very difficult, sir. I can't understand anything like in
don't
the
worry.
exam.
It will take time because don't worry. So
Okay.
exam or exam, okay. Need to learn in depth.
Oh, okay, sir.
Yeah. Okay.
Yes,
So
sir.
let's start a discussion. Laws of motion. Today we will learn angle of friction. Already we have learned, just revision is going on to brush up the concept. There,
Okay, sir.
angle of friction means R is the, what is R? R is the resultant contact force. Clear?
Yes, sir.
Show you also. R is the resultant contact force, and one component is normal, one component is limiting friction. That is the FL. That is friction. Clear? One is gravity,
Okay.
mg. And phi is the angle of friction. The angle made by the resultant of the normal reaction and the limiting friction with the normal is called angle of friction. Simply means it is the angle made by the result. R is the resultant of FL and normal. FL is this, clear? And this
Yes,
is
sir.
the normal. Resultant of this will be R. And the
Okay,
angle
sir.
made by this R with the normal is known as phi, that is known as angle of friction. Clear?
Yes, sir.
Okay.
Yes, sir.
Suppose a block, stop. Suppose a block of mass m is on a rough horizontal surface. The body is experiencing the limiting friction force under the action of applied force. On this, there is a block having mass m. This block is placed on the rough surface. Clear? You are applying a
Yes,
force.
sir.
Applied force. You are applying a force. Clear? Then
Okay,
this
sir.
body is experiencing the limiting force, limiting friction. Clear? Means you are applying a
Yes, sir.
force up to a certain limit. This block should not move. You are applying a force such that the applied force must be equal to the limiting friction. Clear? This is applied
Okay,
force.
sir.
This is applied force. It must be equal to, block should not move. Clear? Then the angle made is known as angle of friction. Block should not move. Their applied force must be equal to the maximum value of static friction, FL. There, then the angle made by
Yes.
the R with normal is known as, what is R? R is the resultant of normal and the limiting friction. And this phi is known as angle of friction. Okay. This block should not
Okay,
move.
sir.
It should be at rest condition. Clear? Rest. Suppose a block of mass m is placed on a rough horizontal surface. The body is experiencing the limiting friction force under the action of gravity. Then the angle made by the R with normal is known as angle of friction. Their block should not move.
Okay, sir.
Let N be the normal reaction force acting on the block and R be the resultant of normal reaction and the friction force. In the above diagram, OA represent the normal, OB represent the limiting force. There. Now, OAC parallelogram, you know very well. This thing like in triangle OAC, tan theta is perpendicular by this. If this is FL, this is also FL. Clear? Tan phi will be what? Tan phi will be FL by N. Clear? And FL is mu s to N divided by N and N cancel. So mu s will be tan phi. Clear?
Okay, sir.
Any doubt?
No, sir.
This already we have discussed, just a revision is going on. This phi is known as, what is phi? Phi is the angle of friction.
Angle
So
of friction.
angle of direct relation is mu s equal tan phi. This phi is angle of friction. Of friction. Okay.
Okay.
Like this. The greater the angle of friction, greater is the value of coefficient of friction. Clear? More the value of phi, more is the mu s. Clear? If you
Okay, sir.
increase the angle of friction means phi, increase means like this. If this angle increase, this phi increase means mu s increase. Clear? The greater the angle of
Okay.
friction, greater is the value of coefficient of friction. Okay? Is it clear?
Okay, sir. Yes, sir.
Okay. Now tell me.
Sir, angle of friction.
What is the answer?
Uh, Sir, option B.
Option
B.
D, na? Very good. Mu s equal to tan theta, na?
Yes, sir.
Motion of a body on a rough horizontal plane. Clear? Like this. Motion of a body on a rough horizontal surface. Consider a rough horizontal surface on which a block having mass is placed. Clear? P
Okay,
is the
sir.
force applied on the block, which is greater than the limiting frictional force. Clear? If it is moving with a more than, if you are applying a force that is P more than FL, then it is confirmed. This block will have some acceleration. And if this block is having some acceleration, there is kinetic friction. This is kinetic friction. Clear?
Okay, sir.
And this kinetic friction always opposes the relative motion. So what is the relative motion of this block? With respect to floor, it is going in the rightward direction. Here kinetic friction Fk will act on the body. Let small a be the acceleration of the body, then the net force acting on the body will be how much? Like this free body diagram. Clear?
Okay, sir.
This is friction. Clear? Net force will be E minus Fk now. Just check. E minus Fk. Net force is equal to mass into acceleration. It is going in the x direction. Clear? See, it is net force in x direction will be mass of the system into acceleration in x direction. In x direction, net force will be P in the right, Fk in the left. There, m is the mass of system, ax is the acceleration in x direction. Is it clear? Fk will be
Yes, sir.
qk mg m. Okay,
Okay, sir.
like this. Clear? So
Yes, sir.
you got the acceleration. We can find the distance. How will you find the distance? As is equal to ut plus half at square. You can find now. You got the So using equation 1, the distance has moved with some time t given at the equation, the velocity can be calculated with the help of kinematic equation. We can apply. Clear?
Okay, sir.
Next is motion of a body on a rough inclined plane. Rough inclined plane. Inclined plane is just like this. Inclined plane is just like this. Body is placed like this. Clear?
Okay.
So what is plane? See, this is the plane. Inclined plane. This theta. This is known as angle of inclination. Clear? The inclined plane. This is known as
Okay.
angle of inclination. Kitna angle? How much inclined? Clear?
Yes, sir.
Consider a body of mass m placed on a rough inclined plane, which makes an angle theta with horizontal. When an applied force acts on the body, frictional force comes into play. If it exceeds the limiting friction, the body, then the body is ready to slide. Meaning is what? See, if you draw the free body diagram, this is the inclined plane. Clear? On this inclined
Okay.
plane, this block is placed like this. One is gravity, mg. This is theta, 90. This is 90 minus theta. Clear? This is normal. If this is theta, this is also 90 minus theta. This is theta. Clear?
Yes,
One
sir.
component of mg will be mg cos 90 minus theta. It is mg sin theta. And one component will be mg cos theta. This is normal. So mg sin theta is responsible for this block to go down. Clear?
Okay, sir.
And there is one friction, then friction will be like this. Clear? Friction always opposes the motion. Clear?
Relative motion. Yes, sir.
Is it clear to you?
Yes, sir.
The force acting on this block is weight. That is has two component. One is normal to the inclined plane and one is parallel to the inclined. So mg sin theta is parallel to the inclined plane and mg cos theta is perpendicular to the plane, inclined plane. Okay.
Okay, sir.
Now normal reaction perpendicular to the plane, frictional force F in the upward direction parallel to the inclined plane. Why it is parallel? Because which force is mg sin theta is a force which is responsible for the motion of this block. So this is the applied force. This is the F applied. Clear? So friction always
Okay.
opposes the relative motion
Relative.
of the block or tendency of motion. So it has tendency to go this direction. So it will always oppose this. If a body is at rest or the inclined plane, then mg sin theta balance the body. A body is at rest means which friction will be here?
Static friction.
Static. Clear? Then mg sin theta will balance. Sorry, FL will balance the what? Mg sin theta. Clear?
Okay,
The
sir.
body is at rest on the inclined plane. The mg sin theta balance the static friction. That's what I'm saying. The normal reaction will be balanced by mg cos theta. You please tell me. It is very easy. This F is the static friction. Clear? If body is at rest means static friction will be equal to mg sin theta. Clear?
Okay, sir.
The static friction. If it is at rest. Clear? And n will be balancing the mg cos theta. There is no motion in the y direction. Clear?
Yes, sir.
The angle of repose. What is angle of repose? Angle of friction is clear. Angle of friction means
Yes.
it is the angle made by the resultant of normal and the friction, normal and the frictional force with a normal. When the block is at rest. Clear? It is the resultant
Okay.
of R is the resultant of limiting friction and the normal reaction. The angle made by the R is a resultant contact force. Angle made by with the normal is known as angle of friction. static condition. Okay, it should not move. Now, what is repose?
Okay.
Repose means what is repose? If I ask what is angle of repose, the angle of repose is defined as the angle of inclined plane at which a body placed on it just begin to slide. Just begin to slide means it is not slide. It is about to slide. It is going to slide. It is going to start. There, meaning is what? Like if you look at me, just a minute. Am I visible? Like, for example, this is the inclined plane. Here, this is inclined plane. This angle is made by the inclined plane. Here, if I
Yes,
kept
sir.
this object, you see this object. If I kept the object on this, and I'm increasing the inclination of the inclined plane, the angle at which this object is begin to slide. That angle is known as angle of repose. Clear?
Repose. Yes, sir.
You want to do this experiment, you can do at your home. Here, the angle of repose is defined as the angle of inclined plane at which a body placed on it just begins to slide. Means it is not moving, it is just begin to slide. Here, now you please tell me,
Okay.
this body, you are increasing this alpha. You are increasing alpha. This mg sin alpha will also increase. Here, and FL is what? FL is mu s and n will be mg cos alpha. There,
Okay, sir.
and applied force is mg sin alpha. So if you increase this alpha, inclined plane, this angle if you increase, this is also increased, this is also increased.
Sir, then this angle is also alpha now, sir. Then both are same.
What?
Sir, the angle bit friction is also alpha only now, sir.
Angle of friction.
Sorry, sir, that the angle here.
This angle is not angle of friction. This is not a R. Okay.
Okay, sir.
What is R? R is different. R is the resultant of limiting friction and normal friction.
Okay, sir.
This is different.
Then
Okay.
this alpha and this alpha is same, sir.
This alpha is same.
Oh, how, sir? How they both are same?
See, they have shown like this. I will show you. Mg is like this. This is alpha. This is normal. This is 90. This is 90. This is 90 minus alpha. This is alpha.
Okay, sir.
So mg cos alpha. Mg sin alpha. And this is limiting friction. Okay.
Yes, sir.
Equilibrium on a inclined plane. Okay. Stop that one.
Yes,
Mass is coming. Wait, what? There. Wait. Stop. Clear?
Okay.
So angle of repose defined is the angle of inclined plane at which a body placed on it just begin to slide. Angle of repose does not depend on the mass of the object as well as its area of contact. It's very, very important. They can ask, does angle of repose depend on the mass and area of contact? No. This is concept, okay? But it depends
Okay.
on the relative smoothness of the surface in contact. For a given pair of surfaces, the angle of repose remains constant. There, it
Okay,
depends
sir.
on the medium or type of nature of the surface. Clear?
Yes, sir.
It depends on the relative smoothness of the surface in contact. For a given pair of surfaces, the angle of repose also remain constant. Okay.
Okay, sir.
Let us consider a block of mass m at rest on an inclined plane, which makes an angle in limiting equilibrium alpha with horizontal. Limiting equilibrium means when FL balance the mg sin alpha. Here it is not moving like this. See, okay. Let us consider a block having this alpha. Limiting equilibrium means mg sin alpha equal what? This half L. Okay.
Okay, sir.
This is not moving actually. Meaning is
Static friction.
limiting equilibrium means mg sin alpha equal FL. FL is mu s and will be mg cos alpha. So this is mu s equal tan alpha. So this alpha is known as angle of repose. Here it is about to move. Just begin to slide. It is not moving. Okay. This angle alpha na.
Okay.
This
Yes,
angle
sir.
alpha depends on what? Mu s. Mu s. This angle alpha depends on mu s. Mu s is a characteristic of surface in contact. That is why this alpha depends on nature of surface. Okay. So coefficient of
Okay, sir.
friction depends on simply nature. Okay. It does not depends on area of contact. It does not depends on mass. Okay. It depends on nature. Clear? Will say if you ask me like FL, there also angle of friction, angle of repose. I think if you get carefully here, just begin to slide. Here one condition is just begin to slide. But angle of friction also I think we are taking the normal there and the normal and FL. Here like we are not taking the normal and FL. Here it is
Sir, can you
slide.
please repeat it again?
I'm saying like here this is the angle of repose means it is the angle at which a object is begin to slide.
Yes, sir.
It is not moving. Begin to slide means this mg sin alpha must be equal to FL. It is not moving. Clear?
Okay, sir. Yes, sir.
This is the angle of repose. Clear?
Yes, sir.
Clear? So I will share one more slide. Skip now. Is this clear to you?
Yes, sir. Yes, sir.
Think possible.
Yes, sir. Visible, sir.
So now we will understand. This is a slide. It's part of that only. Now we will learn here some
Okay.
numerical also. Body just ready to slide. Sliding down. That is angle of repose on. Ready to slide means
Okay.
just begin to slide. Since the body is in equilibrium, the net force on it should be equal to 0. Therefore, mg sin alpha becomes equal to the limiting force. That's what I'm telling. Just begin to slide condition is limiting friction must be equal to applied force. There,
Okay, sir.
there means
Yes, sir.
body does not move at angle of repose. If you increase little bit more than that, this will move. There, that's what I have told.
Yes,
Na?
sir.
mg sin alpha equal to mu s. This is what I have told. Mu s equal tan alpha. So alpha there. In case of inclined plane, the angle of repose is equal to the angle of friction. Now this is very important. Learn this. Here, in case of angle of repose, sorry, in case of inclined plane, the angle of repose is behave just like a angle of friction there. There,
Okay, sir.
because here condition also we are same condition we are applying. There also like if you look at carefully, FL, FG, just understand. Clear? There also rest condition. Clear?
Okay, sir. Sir, then
Body slide.
that time when I said that alpha is equal to theta, then that's correct only, no, sir?
In actually in inclined plane, see if this is not inclined, if it is like that, then FL will be this, normal will be this. Here, this is
Yes, sir.
the
Okay.
angle of friction. If the surface is not inclined, let us suppose if surface is not inclined, block is placed like this. This is the FL. Okay, normal is this. This is the weight. Okay, normal. This is R. This is angle of friction. But if you make not the surface inclined
Yes, sir.
like this, then if you look at carefully, this normal is okay. Gravity be like this, perpendicular. Here, FL will be FL always what opposes the applied force we are applying like this. Now they are P. Here, this P is equal to
Yes,
FL.
sir.
You remember, applied force must be FL. Here, but here applied force is not P. One component of mg. That is 90 minus alpha. So mg sin alpha. This is mg cos alpha. Clear? FL will be here
Yes,
this direction. If you look at carefully also, na, this is 90 minus alpha, this is alpha, this is alpha. This is resultant R, FL and N. Clear?
okay, sir.
Same thing is here, okay? But confusion, don't have confusion. Angle of repose is same as angle of friction. Clear?
Yes, sir.
Condition is body should not move. Clear? Friction must be limiting friction. Okay?
Okay, sir.
When the angle of friction is more than the angle of repose, then the body slide down with a uniform acceleration. There,
Yes, sir.
simple. If the if the theta is more than alpha, it definitely. What is like we have mentioned simply. If theta is more than alpha, it definitely move. If it is moving, there is kinetic friction. That is clear
Yes, sir.
in this slide. That is only okay. Simple, very simple. Okay, I will explain also. See, this is the inclined plane, and this is the object. See, this is 90.
Sir,
This is
this is
theta.
alpha or theta, sir.
Theta is more than alpha.
Okay, sir.
This is mg cos theta. This is mg
Sin
sin.
theta.
This is, since it is more the angle of repose, then there is a kinetic friction. Clear?
Okay, sir.
Kinetic friction is Kn. N is mg cos theta. And that force, in which direction this block is moving? This direction? Clear? This direction, na?
Yes, sir.
This direction is moving. So net force equal mass into acceleration. Now, you can take any direction to positive, any direction. You can take horizon here. Horizon. This is plus x. This is plus y. Okay?
Okay, sir.
Plus y. Along acceleration, you can take x-axis. There. So here positive x-axis, positive y-axis, negative. So net force mg sin theta will be along positive. There. Fk in the negative direction equal I'm into A. We need to find A. Okay.
Okay, sir.
Fk will be how much? Mu k and will be mg cos theta. This question they have asked. Direct question. And M cancel. This relation remember, okay, A is equal to G sin theta, G sin theta minus mu K G cos theta. Okay, this is the acceleration formula. Direct formula, if you remember now, they can ask many questions.
Okay, sir.
Same thing I have written. Here, Dinesh.
Yes, sir.
Wait, charge. Charge. Okay. In the okay. Is it clear? I think you can got this relation. You see this relation I is equal to G
Yes.
sin theta. Okay.
Yes, sir.
चलो हाँ हुआ करता हूँ ये रास्ते में हाँ ठीक है मैं कल रास्ते में पहुँच रहा हूँ ठीक है वो ओके 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 बस करता हूँ 18 ओके ओके ओके
Okay, sir.
now velocity and acceleration of sliding body sliding मतलब इसके have acceleration okay
Okay, sir.
so consider a body of mass m that is placed on a rough inclined plane having coefficient of friction mu k there the body slide down the
Okay,
plane when the angle of inclination is greater than angle of repose. That is concept. It gains an acceleration of A is equal to G sin theta minus mu k g cos. This is very important relation. You should remember this. When body is coming down, okay, when it is going down, A will be G sin theta minus 2 kg cos theta. Remember, this formula you will apply when body is going down. Okay,
Okay, sir.
A to B. There,
Yes, sir.
velocity at the bottom of the inclined plane. What is the velocity of? Initially, let us acceleration you got. Then v square equal to u square plus 2as you can apply to got the velocity at the bottom of the inclined plane. There, initially the body start from rest and attain the velocity v on reaching the bottom of the inclined plane. Very easy. Here, like this. This is the inclined plane. Body start from A. Clear? This is the distance L. Here velocity will be what? V square. U square 0 initial velocity. Rest.
Okay.
A you already saw. What is A? Displacement L. The value you get. Clear? Very easy. Time. This is very basic question. Okay, S is equal to ut plus half at square. You can apply and solve. No need to. I don't want. I don't think like I should give an explanation for that. Clear?
No, sir, I can find sir.
Yeah, that's why you should not learn these formulas. Learn only one formula. Then angle of when inclined plane has angle more than angle of repose. Acceleration when body is going down. Acceleration is A will be g sin theta minus kg cos theta. This is very important. Body
Okay.
slide up the plane. Now, if body is going to slide, first case, when body is going to slide down the plane. Down the plane means it is coming down. Okay. Then acceleration formula will be this. Okay.
Okay, sir.
But if a body is going up the plane like this body is going up. Up means like this. There, up like this.
Okay.
You are taking this block, sliding up to the plane. Up. Then here formula will be A will be direct. G sin theta plus mu kg plus only cos theta. Clear?
Okay, sir.
Simple minus plus different. Same thing you will get. Okay, I'm not saying anything. You can check also. Same thing. Okay,
Okay.
this is you will use when body is going to up the this corner. Very important. Projected. If a body is projected with an initial velocity u, to slide up the things are not important. It's 1 minute. Okay.
Hello, sir.
Wait. It is some messages
Okay.
came. One more class actually. Okay. So consider
Okay.
motion of the body on a smooth inclined plane. Yeah. Smooth means like there is no you can say frictionless. Okay.
Okay. Okay, sir.
That is simple question. If there is no friction, you please tell me. Is there any means to say like A is equal to this formula? A is equal to G sin theta minus mu kg cos theta. If there is no friction, then mu k will be 0. Here,
Yes, sir.
confirm like A will be G sin theta. What is the need to derive? There is no friction, then
Okay.
mu k is 0. Now, smooth surface. And mu k is 0. Here,
Yes, sir.
that is the case. Okay.
Okay, sir.
This is simply wastage of time. Body slide up and simple wastage of time. Same thing, okay.
Okay, sir.
Now this is very important. Pulling and pushing of a lawn roller on a rough horizontal. Lawn roller, you know, roller.
Yes, sir. Yes, sir.
So consider a lawn roller of mass M on a rough horizontal surface is pulled by an inclined plane like this. Here, at an angle
Okay, sir.
theta, you are lawn roller. You are applying a force F. One component is F cos theta. One component is F sin theta. Okay. Weight is mg and is normal. The force is resolved is common sense. Okay. So it is common sense in vertical direction n plus F sin theta will be mg. Clear?
Okay, sir.
Since it is a roller, then which friction will be here? Rolling friction. Which friction?
Sir, you didn't teach that rolling friction, sir.
It is roll na. When any wheel is going to roll na, then which friction?
Yes, sir.
Rolling friction. Rolling
Rolling
friction
friction.
is in place of mu s, it is mu r. Rolling friction. Coefficient of
Okay,
rolling.
sir.
Meaning is same na. But it is not that much important. Say if
Okay.
wheel, if there is a roll surface, if there is a wheel means something is going to roll on a rough surface. There is rolling friction.
Okay, sir.
That is me. Mu r is coefficient of rolling friction. That is why m will be f. F is mu r when clear.
Okay, sir.
So f will be what? Mu r. Very easy. If you wish, you can here also m plus f sin theta. Well, then m will be what? Mg minus f sin. Clear?
Okay, sir.
Then if you ask me like what is a f Rolling friction, it will be mu r into m. M will be what? Mg minus f sin theta. G minus f else. Same thing we have solved. Okay.
Okay.
This is pulling. Okay. What we are doing here? Pulling. Check. We are pulling. In case of pulling, how much
Okay.
friction? Remember, okay, mg minus f sin theta. Now, in case of pushing the lawn roller, you are pushing like this. You are
G
pushing.
plus.
Like you are pushing. You know, yeah,
Okay.
like pushing. Pulling means like this. Clear?
Okay, sir.
Clear? Lawn roller is like this. In earlier case you are pulling like this. Pull. This is pulling. This case you are pushing.
Okay, sir. The sign changes.
Yeah. Pushing. This is push.
Okay, sir.
Okay.
Okay, sir.
So simple free body diagram I think is clear to you. Here n will be. That is simple. Now you can tag. In which case rolling friction is more? In first case, in pulling case,
Sir, in
it is minus na.
pulling, sir.
Pulling is mg minus f sin theta. So
Yes,
rolling
sir.
friction is more in there in pushing.
Okay, sir.
You can check na mg plus there mg minus. So where it is more. So friction force while pulling is less than while pushing. That is why pulling is easier. Yeah.
Okay, sir.
Help me out. Today I
Sir,
will
1 minute.
finish your question part totally. On Sunday I will start circular. Okay.
Sir, option D.
Option C. Pulling, the vertical component of the pulling force act upward. Clear? If you check here, vertical component क्या है? What is the vertical component here? Vertical component of pulling force is down. Same force F, their vertical component is up. F sin theta. Here F sin theta is pushing case, it is down. Clear?
Okay, sir.
That is the answer. So vertical component of the pulling force act upward and thereby decreases the. That is why it is easier. Here they are asking why pulling is easier, because they are component of pulling force acting upwards. Okay.
Sir, but in rolling friction, friction acts in the direction of motion only, no, sir?
In rolling friction,
Friction acts in the direction of the motion only, no, sir?
how is it possible?
Sir,
Friction always oppose, na. I didn't show you the direction. Wait. You can check. Friction force is opposite.
sir, one minute, sir. If the
F cos
if
theta
the
is
if it
in
is
the
a
right now. F cos theta is responsible for the motion in the right direction. Now, friction is rolling friction is left only.
sir, in the class 8, I was taught that friction in rolling friction acts in the direction.
Never. Remember one thing. Rolling friction always oppose. For us, during walking, when we walk now, in that case,
Yes.
friction helps us to move. But friction always opposes the motion. Whether it is rolling, pulling, you can check also. Like small f will always, you can check, oppose it. You please tell me if the rolling friction is acting in the direction of motion, then how wheel stop? Who is stopping the wheel? When you are not giving the acceleration, then the wheel stop by its own because of this rolling friction. Huh? The car
Okay,
wheel,
sir.
how it stop? When friction is opposes now, when friction opposes, if friction is in the direction of motion, then it will never stop.
Okay, sir.
Yeah,
Yes,
ask
sir.
question to yourself, na? Tell me. Oh, sorry. Tell me.
Static friction,
No,
sir,
coefficient of
less than
static
1.
friction. Very good. It is more than 0, like this. Usually less than 1. So this is complete. Maybe tomorrow, let me show you. Tomorrow I will discuss, not tomorrow, I will discuss maybe on Sunday, circular motion. Friction is finished. Whatever maximum it is possible friction, not a single question you can't solve. If you know the concept, you can solve any question. Okay, finish.
Okay, sir.
Circular motion, last topic I will discuss maybe Sunday or before Sunday, I will inform. Because maybe I will be traveling, but I will
Okay,
definitely complete the question. No need to. Circular motion is left. After this, I will
okay,
start work energy power. Then center of mass, those things. Clear? No need. Clear to you?
okay, sir. Yes, sir. Clear,
Yeah.
sir.
Family, if you have more clarity. Practice question, okay? Ask question, ask doubt,
Okay, sir.
ask solve numericals. Okay, Dinesh. Bye bye. Take
Okay.
care. Thank you. Bye bye.
Okay, thank you, sir. Bye, sir.